Welcome to Schrödinger's Chat, the podcast where I explore the real science behind the biggest questions in the universe, as well as some of the quirkier science we encounter every day. I'm Anna, a sixth form physics student with a lot of curiosity and a passion for understanding how the world works. From the smallest particles to the largest galaxies, join me as we uncover the mysteries and wonders of the universe and explore how physics shapes the world around us. Hello, welcome back. Firstly, I'd like to apologise that it's been so long since I've released an episode. Between mock exams and university applications, it's been rather busy, and I'm actually about to go into the final 3 or 4 months before I take my actual A levels, so we're in for another few busy weeks. But hopefully, we should be returning to normal by the summer, and I'll see how many episodes I can do over the next 3 months, but apologies if A levels get in the way for a bit. Anyway, in this episode, it's time for another Legends and Lab Coats, the series within this podcast all about the lives and work of legendary scientists. In the previous and first episode of Legends and Lab Coats, the theme was pioneers, and we looked at 3 scientists, Newton, Meitner and Maxwell, and how their unique and revolutionary ideas changed the course of physics. If you missed that episode, feel free to pause now, go and listen to that one, and come back. But if you didn't listen to it, you're not going to miss out on what we're discussing today. Today, we're looking at the invisible geniuses, 3 scientists who have fallen into relative obscurity or whose work was overshadowed by others at the time. But it's time they get the recognition they deserve. So our 3 legends today are Rosalind Franklin, Alfred Russel Wallace, and Jocelyn Bell Burnell. Hopefully, this episode will enlighten you about some of these amazing scientists who you may not have heard of, and maybe highlight just how many unseen, amazing people were really behind famous groundbreaking discoveries. Before we get started, a quick reminder to leave a review or comment if you like this podcast, and check out the podcast Instagram page, Schrödinger's Chat Podcast on Instagram. Here I post all sorts from extra bits relating to the episodes, STEM book recommendations, and other nerdy science things, so if that sounds like something you would enjoy, do go and have a look. Back to the episode. First up, let's talk about someone whose work literally shaped our understanding of life, Rosalind Franklin. She's one of the most famous examples of someone whose brilliance was overshadowed in her time. Rosalind was born in London in 1920 into a prominent Jewish family. From a young age, she excelled at school and developed a deep love for science. She went on to study physics and chemistry at Cambridge University, unsurprisingly specialising in physical chemistry. Early in her career, she did research on coal and carbon, work that helped improve gas mask filters during the Second World War. So even before the discovery she is known for now, she was already contributing great things to science and to Britain's war effort. In the mid-1950s, Franklin joined King's College London to study DNA using a technique called X-ray crystallography. This is where you shine X-rays through a crystal, and the pattern of shadows can reveal the atomic structure inside, which I think is so cool. The fact that we can analyse atomic structure just from shadows is amazing. In King's College in 1952, Rosalind Franklin, along with her PhD student Raymond Gosling, produced what we now call Photo 51, an X-ray diffraction image of DNA that revealed its helical structure. Now seems like a good point to quickly talk about the structure of DNA, deoxyribonucleic acid. DNA is made up of many nucleotides. These are the basic building blocks. A nucleotide consists of a deoxyribose sugar, a phosphate group, and one of the 4 bases, adenine, cytosine, thymine, and guanine. Each nucleotide connects to another, depending on the base it has. Adenine pairs with thymine, and cytosine pairs with guanine. This structure continues with alternating sugar and phosphate molecules creating 2 long strands on each side of paired bases, which is aptly called the sugar-phosphate backbone. These strands are twisted around each other, creating the double helix structure, which kind of looks like a twisted ladder. Photo 51 showed a distinctive X pattern, which suggested the spiral shape of DNA, and this crucial piece of evidence was essential for Francis Crick and James Watson to make their discovery of the double helix DNA structure. Now, here it gets slightly messy. Franklin's colleague Maurice Wilkins took over supervision of her PhD student, Gosling. Wilkins then showed Photo 51 to James Watson and Francis Crick, who went on to use it to finalise their DNA model. When they published their findings, they failed to give Franklin any credit for her work, so she was effectively written out of the discovery. Franklin published her own detailed analysis, but when the Nobel Prize was awarded in 1962, it went to Watson, Crick, and Maurice Wilkins. Rosalind had died in 1958, and the Nobel Prize wasn't awarded posthumously. So, frustratingly, she wasn't officially recognised. This is so frustrating, particularly as the discovery of the structure of DNA was so groundbreaking. It has allowed us to develop all sorts of new areas for research in DNA, like understanding genetic diseases and how to predict and treat them, drug development, and genetic engineering. The discovery of the structure of DNA also helped to prove other scientific theories about evolution and genetics, like Gregor Mendel's ideas about genetics and Charles Darwin's theory of evolution. This leads us perfectly onto our next scientist, Alfred Russel Wallace. We're moving from the microscopic chemical world of DNA to the sweeping expanse of evolution. When I say evolution and scientist in the same sentence, I bet you're immediately thinking of Charles Darwin, and rightly so. His work was revolutionary, controversial in its time, and one of the most important theories in science. But Darwin wasn't the only person thinking about evolution in his time. It's time to talk about our next invisible scientist, Alfred Russel Wallace. Wallace was born in 1823 in Wales into a modest family. Unlike Franklin, he didn't have a privileged academic path. In fact, much of his education was informal. But he had an insatiable curiosity about the natural world. He loved exploring, collecting specimens, and asking big questions about how life works. Basically, how any passionate scientist starts out. When he got a job as a teacher in Leicester, he met Henry Walter Bates, a local naturalist. It was Bates who introduced Wallace to beetle collecting, and in the mid-19th century, Wallace and Bates embarked on an expedition to Brazil. They arrived in the Amazon in 1848, and later the Malay archipelago. Over 4 years, they collected thousands of specimens, selling a few to finance their travels, and made meticulous field notes recording their findings. Devastatingly, on the trip back to England, Wallace's ship caught fire and sank whilst crossing the Atlantic, taking many of his field notes and precious specimens with it. Fortunately, Wallace survived, and within a year he had planned and embarked upon another expedition, travelling this time to East Asia. I have to say, his determination is just unmatched. He didn't seem to waste any time sulking over lost specimens and work, but rather only let that fuel his desire to set off on another adventure, which is really very admirable. By 1854, Wallace was in Asia and started at the Malay archipelago, which today on a map is Malaysia and Indonesia. Here, Wallace spent 8 years collecting 125,660 specimens, a truly staggering number, more than 5,000 of which were species that were yet undiscovered by Western scientists. In fact, something wonderful about Alfred Russel Wallace's work is that in his field notes he talks about his local guide, R. Lee, and how they helped and worked with each other as they collected specimens. This was such an unusual thing for his time, and is one of the few times where an indigenous people's contributions to natural history have been acknowledged, recorded, and praised. This is so important as it's easy to remember Western explorers who, quote-unquote, discovered various lands and animals and plants, and so on, but we often overlook the fact that indigenous people of these regions already held vast amounts of knowledge about their lands and its wildlife. So I think it's quite refreshing to see a scientist who acknowledged such things, especially in a time where this was not at all the norm. Alfred Russel Wallace recorded his findings in his travel book called The Malay Archipelago. He wrote vibrant accounts of his findings and explorations, illustrations of wildlife, and meetings with the local people. Over years of detailed observation of the ecosystems and wildlife, Alfred Russel Wallace noticed a pattern in the spread of species around the archipelago. He realised there was a difference between the wildlife in 2 distinct areas of the archipelago and came up with an imaginary line that split these 2 regions in half, one containing wildlife only found in the Australian region and the other half wildlife only contained in the Asian region. This is called the Wallace Line and lies just to the east of Borneo. He noticed that species adapt to their environment and that the traits that help survival are more likely to be passed on, meaning animals with unique features were found in specific areas depending on the ecosystems and conditions of those areas. Wallace had started to piece together natural selection and evolution. In 1858, he sent an essay to Darwin outlining his theory. Darwin was shocked, as he had been developing the same idea for decades. Now, unlike in our previous Legends and Lab Coats episode, where we looked at the rivalry between Newton and Hooke and who actually came up with the theory of gravitation, Wallace had come up with the same theory completely independently. He was actually ill and isolated on an island in Indonesia when he sent his letter containing his theories to Darwin, proving that he couldn't possibly have stolen any ideas. Darwin was actually delighted that Wallace had made the same discoveries, and this led to a joint presentation of their work to the Linnean Society of London. A year later, Darwin published his book, The Origin of Species, which quickly served to establish Darwin as the father of evolution. However, Wallace didn't seem to mind being in the shadow of Darwin. He was humble and more interested in discovery than recognition. He remained one of Darwin's greatest supporters and still gained high recognition in the scientific community due to his discovery and Darwin's support of his work. Whilst he is still overshadowed by Darwin, it is incredible that Alfred Russel Wallace independently reached one of the most revolutionary ideas in biology. His observations and writings helped shape the field of evolutionary biology, and the story of joint discovery is actually very heartwarming. It shows how we can cooperate and support fellow thinkers in the scientific community. In fact, Wallace's story is all about humility, cooperation, and genuine passion. I think it's inspiring that he was intensely dedicated to scientific discovery even when he didn't get all the recognition, and even persevered when his ship sank and his work was all but destroyed. I think he reminds us that brilliance can be shared, and that at the root of grand scientific discoveries and recognition, there is actually just someone who is relentlessly curious, resilient, and unapologetically passionate about the world. For our final legend and lab coat today, let's talk about Jocelyn Bell Burnell, an astronomer whose discovery changed how we understand the universe, yet for decades her name was largely missing from the headlines. Jocelyn was born in Northern Ireland in 1943 and had a keen interest in science from a young age. She studied physics at the University of Glasgow and went on to Cambridge for her postgraduate work. There she began working on radio astronomy, which involves using radio telescopes to detect signals from space. At Cambridge, as a PhD student working under Professor Anthony Hewish, Burnell spent time helping to construct a large radio telescope, which she was using to aid her research on quasars. Quasars are essentially cores of galaxies, where dust and gas that is falling into a supermassive black hole emit a vast range of electromagnetic radiation, making them incredibly luminous. In 1967, while analysing data from the radio telescope for an experiment she was running on quasars, Burnell noticed something strange: a series of regular radio pulses. They were so precise, she even jokingly called them little green men at first. But after consulting with her supervisor and using more sensitive equipment to eliminate other possible causes for the strange pulses, it turned out that Burnell had discovered rapidly rotating neutron stars, or pulsars, that were emitting electromagnetic radiation. This was a completely new type of astronomical object, a huge breakthrough in astrophysics and our understanding of the life and death of stars. However, when the Nobel Prize was awarded in 1974 for the discovery of pulsars, it went to her supervisor Anthony Hewish and colleague Martin Ryle, not to Jocelyn. Many believe her critical role was overlooked because she was a young woman and a PhD student at the time. Even so, Burnell always graciously maintained that the prize was awarded correctly due to her being a student, even though many other scientists protested her exclusion at the time. There does seem to be a theme of overlooked scientists being incredibly humble and having little resentment about not being in the spotlight, instead focusing on their love for the work and discovery for the sake of discovery and nothing else. again showing what I think is an admirable approach to the frustratingly unfair situations. While she missed out on the Nobel Prize, she has since been awarded a plethora of awards and prizes for her work, such as a CBE, the Copley Medal, the Herschel Medal, the Royal Medal, and the Michael Faraday Prize. And that's just to name a few. She has also held many positions at various scientific institutions, including the president of the Institute of Physics, a professor at UCL, and a professorial fellowship at the University of Oxford. Again, just to name a few. So, from being left out from the Nobel Prize, she has gained back the recognition she deserved, and continues to be a prominent figure in astrophysics and communication of science. So, we've journeyed from the literal building blocks of life with Rosalind Franklin, to the sweeping forces of evolution with Alfred Russel Wallace, and out to the stars with Jocelyn Bell Burnell. Whilst their stories are tinged with injustice and frustrating scientific politics, which does highlight a need for cooperation and connection in the scientific community, the theme that seems to run through it for me is resilience, humility, and curiosity. All these legendary scientists continued their work despite their circumstances, fueled by their passion, pure curiosity, and hunger for scientific discovery. They may have been invisible to the world in their time, but they were certainly not irrelevant, and hopefully this episode has helped to bring some awareness to them. I think they all inspire us to remember the true purpose of science, being unapologetically curious and passionate about the world, even when it means not always being in the spotlight. In the words of Jocelyn Bell Burnell herself, science is a quest for understanding. Well, that's all for today. Thank you so much for listening. I hope you've enjoyed this episode, and if you have, remember to leave a review or a rating, and stay tuned for the next episode in the Legends and Lab Coats series. In the meantime, go and check out the podcast Instagram page, and I'll catch you in the next episode. But until then, stay curious, and remember to always channel your inner legend in lab coat. Bye!